Is it going?
Yeah, I think I started. Do I need the mic? I might need.
So I might need to open the URL first.
Hi everyone, my name is Sanjeev, and with my excellent team here, we are pitching for Eugene's Revenge. It almost sounds like George Clooney's comeback. Now, what's happening here is this is a web-based solution application for analyzing and visualizing genomic sequence data sets, which are very varied, very data intensive, and also very difficult to handle by using legacy systems. Eugene is actually an R package developed right here in Australia with the UQ, and that package is a workhorse. It's good, but it did have issues with performance, data representation because of its age, or how long ago ever it was developed, and comparative analysis, which is the current issue with lots of genomic data being produced from different microarrays and different test conditions. Normalizing them for comparative study, is a challenge in itself. So Eugene does that, but to an extent it needs help now with an increasing amount of data. And flexibility, of course, being a legacy system. So we came up with this solution we have developed. The solution is an interactive web visualization application. Now, this is more explained by Jun, who is the coder and the software developer of that. Now, what it's able to do is representation of multiple data dimensions. Just being the new technology and the new tool, it has the capability to represent data much more effectively and visually in many more dimensions. And then we have a gene pair selection, which we'll go through the demo in a short while. And we can have customizable views, so we can actually generate views as the researcher needs. So it is going to be a tool of the future genomic visualization. Thank you. Over to you.
Sorry, that didn't work. Here we go. Can anyone hear me?
Yes.
Yep. So this is the tool that we actually built over the weekend. So just to reiterate, one of the problems that we were finding with previous tools which already existed is that we're dealing with microarray data which has several dimensions to it. And what you find is that with a single XY plot, you can only really capture perhaps 2 dimensions. So what we've tried to design, this will load. Yep.
Show the PDF.
Sure. Sorry, I'll just switch back so you can take a look at.
All right. Is an extension of time?
Question
That's a revenge. That's a revenge. Any questions?
So how does it work?
Yeah.
Just have 30 seconds more, I think.
Sure.
You have that, Elliot?
Yeah.
Right. So yeah, as I was saying, we've got several dimensions to our data. So we have, in this case, we're looking at disease states. So we have several categories here, and basically what this tool allows us to do is filter down our data set based on certain categories. So for example, here we're comparing 2 different genes, and what we can do is we can select a selection of data points and basically interrogate which tissue type, cell type these data points belong to. So again, we're trying to look for patterns in our data. So scientists are looking for patterns. So we might find, there might be an anomalous group of data points up here. And being able to select that. Yep.